Hello, everyone. Welcome to Microsoft Ignite. Welcome to the local session hosted by Microsoft Norway. Today, we have gathered a bunch of great folks who know a lot about machine learning and machine learning operations. So we will have a panel discussion about, what is machine learning operations, why that matters, and share some best practices when it comes to machine learning operations in action. All right, so before we jump into the discussion, I just want to quickly introduce the panelists of today. Actually, I will ask them to make a brief introduction of themselves. Let's start with Stephen.
Yeah, hello, my name's Stephen Allwright. I'm a data scientist working at Elkjøp Nordic. We are the largest electronics retailer in the Nordics. And yeah, I'm really excited to be talking about MLOps today. It's something that we've been focusing a lot on for the past year now, and it's been very valuable for us.
Perfect. Luca?
Sure, thank you, Xiaopeng. I'm Luca. I'm a data scientist at DNV. My background is a mix of data science and engineering. And when I say engineering, I mean the old-fashioned engineering with, structures, beams, that sort of things. Anyway, here in DNV, we see obviously a big moment around the use of machine learning. Likewise, we also see an increasing need in assurance machine learning. And we're following the need closely with our work, in standardizations and recommended practice, as well as auditing of machine learning. We see technologies and processes such as MLOps to be, a game changer and to really have potential also to help some aspects of assurance in the long run. Thank you so much, and thank you, Microsoft, for having me here today.
Thank you for joining us. Let's move on to Evan.
Yeah, thank you, Xiaopeng. Very good to be here. My name is Øyvind Hetland. I work as a senior data scientist consultant for a company called Crayon in Meta. We work as consultants for customers both nationally in Norway and globally. I have a background in physics myself, in electromagnetics, and now I'm trying to do my best in building machine learning-based solutions for customers. So I'm really excited to have the opportunity to discuss some MLOps here today. So thanks for inviting me.
Fantastic. And then Shoresh. You're muted.
Yeah, sorry. Hello, everyone. Thanks, Xiaopeng, for having me here. My name is Shoresh Ghazari. I'm cloud solution architect for AI and machine learning. And then I am mainly helping the Microsoft customer in oil and gas industry and manufacturing. Thanks.
Fantastic. And obviously, I forgot to introduce myself. So for those who do not know me in the audience, I assume the majority. My name is Xiaopeng. I work in Microsoft Norway. So I'm super focused on the entire Azure portfolio. So working a lot with our cloud infrastructure, data platforms, AI, machine learning, etc. when it comes to go-to-market. So just a few reminders. So this is a live session. So this is not a drill. And also, we are going to have a small Q&A session by the end. So if you have questions, please feel free to put them in a chat window, and we will address them later on together with the panelists. All right, so let's go into the discussion then. Let's start with defining machine learning operations. I mean, obviously, there has been a lot of buzzwords when it comes to AI and machine learning, and people have probably heard about DevOps, and some folks, heard about, data ops. And today we're talking about ML ops. So what is machine learning operations? What is ML ops? Maybe we can start by having you share some perspective, Shoresh.
Yes, yeah, sure. Actually, let me start with some numbers. In 2019, according to the VentureBeat AI reports, 87% of the ML models didn't make into the production. So actually, business needed a procedure to decrease this failing rate. So regarding the first part of your questions, MLOps is set up the best practice for business to run AI successfully. So all is about how to bring the ML to the production. So in reality, it's bring together people, process, and the platform. For example, enable data science and IT teams to collaborate more effectively, to accelerate the entire machine learning lifecycle, like speed up the model development. Also, basically, it's bringing together different bunch of the workflow as well. As you know, you have your data science workflow, data engineering, data processing workflow, as well as your ML engineering. But of course, is a difference between the MLOps with the DevOps, but in reality, MLOps is based on the DevOps principle. So it's not something absolutely new, but compared to DevOps and the normal software development, you have two bigger artifacts that you are dealing with here, data and model. So basically, there is a difference between DevOps, which try to bring the software code to the production, than the MLOps, which trying to bring ML to the production. Because as you know, software code are somehow statistic, but what about the data? Data is changing, and machine learning model are learning and adapting to the new data. And since model reuse and the data reuse are different than the software reuse, it makes somehow the environment more complex and they make MLOps unique to it.
Yeah, makes sense. Because you did mention that DevOps and MLOps shares a lot when it comes to the methodology. But then obviously there are some unique characteristics when it comes to machine learning. Thinking about the explorative analysis of data and thinking about the whole more experimental mindset during the whole machine learning building process, and also the continuous optimization and training of the model. So with that said, do you think there's anything particular we should pay attention to when a team that is familiar with DevOps but just getting started with machine learning operations?
Actually, it's very important that for any teams that start from the DevOps principle, they have to get familiar with the whole process of the life cycle of the machine learning, from, for example, data ingestion, data training, model training, and also validation and the whole process. So as long as they get familiar with these tools and the concept, they can jump in, for example, for the MLOps. So I think that the key is that how understand the data and the model, which are different from the software code. As long as they get familiar themselves with these two options, these two artifacts, it will be much easier for them to jump.
Makes sense. All right. I also do know that Stephen from L-Ship, you guys have been practicing MLOps for a while, and obviously you're doing that on Azure, because that's the preferred cloud for you guys. I want to hear some thoughts from you as well. So, I mean, what is machine learning operation from your experience, and how do you compare that with DevOps?
Yeah, I agree with a lot of what Shoresh was saying. I think we see MLOps as very much a subset of DevOps, but with just different artifacts that we're using. So as Shoresh was saying, instead of software that we're developing, the artifact that we're creating at the end of it is a machine learning model in production. So for us in L-Ship, it's been a huge focus for us in the past year. What we actually did, and I think is definitely a key learning from us from implementing MLOps, is we also implemented a Python package, an internal Python package internally to help us streamline the MLOps workflow. Because one of the problems with, or not necessarily the problems, but one of the challenges for MLOps is that if you get new data scientists on board, then understanding the whole infrastructure workflow in order for you to put your machine learning model into production can be quite a steep learning curve. And also we wanted to be able to streamline the processes so that it was easy for people to follow. Because obviously if you have an MLOps system, that it means you're adding more moving parts into your workflow as a data scientist. And so we created this Python package to make it really easy to follow, to make sure that all of our machine learning models were created in the right way and created within the MLOps system that we have, which makes it easy to maintain. It makes it easy for other people, different team members, to come in and look at the code and understand what's going on. And critically, whilst it being a very interesting area, the key thing for us is that it decreases the time to production. That's the reason why we did it. It decreases time to production and it makes maintainability easier. So that's for us our key reason for doing it. And it's been it involves a lot of work in the beginning, but already now we're noticing that when we have an idea and we create a model, the time it takes to get it into end users' hands is drastically decreased.
Makes sense. And thanks for sharing your real life experience. And I think you guys, I mean, Shorish and Stephen, you have touched upon a little bit on, the why part of MLOps already. But let's double click on that topic. So why do we need machine learning operations? So what's the value really, for an organization to use machine learning operations? I mean, it's a cool technology for sure. I know, some techies really just want to use new technology for the sake of using it. But I think, we need to think about the business value that we're creating for the organization that we're working for. So on that one, do you want to share some thoughts, Evan? So why do we need machine learning operations?
Yeah, sure. Yeah, I think machine learning is hard. And getting machine learning into production in a reliable and maintainable way that doesn't just collapse in on itself or stop working a couple of months after you've deployed the first model, that's hard. And also, if we zoom out a little bit on the DevOps side, we've all heard statistics like 80% of all data science-based projects fail to reach production, stuff like this. And I think it's an indication that there's a lack of maturity and there's a lot to learn still in how we mix traditional software development and the best of DevOps with the best of MLOps, so to speak, or how we mix that data-centric part into software development projects. I think in terms of how to create value, I think for many companies, it's all about de-risking ML projects. So basically, machine learning introduces a new set of risks, the technical risk. So in a lot of aspects, the technical software development, we've gotten such mature tooling and so much experience in how to build solutions that the technical risk that you have to tell your manager, like, yeah, we can actually not technically solve this problem. That risk is very low on software projects these days. But once you introduce machine learning, that becomes a real risk. And at the same time, after your model is deployed, Shoresh mentioned the life cycle aspect, which I think is incredibly important. How do you make sure that your model keeps generating value even after it's been deployed? And that comes down to having a planned and responsible lifecycle handling of the model and the solution you've built, both in monitoring it, making sure it delivers what you think it delivers, having people know how to fix an issue that pops up. We've seen multiple times that if a software API fails, then the operations engineers know what to do. But if a machine learning solution fails, they have to try to get the data scientist on the call and desperately try to figure out how to fix this thing that they don't want to touch and they don't know how to touch. So in terms of value creation, also, MLOps is equally about people and having people understand each other's situations, needs, understand what's easy, what's hard. Yeah, these things.
Can I jump in on that actually?
Absolutely.
I totally agree. I think that for us, at least, we've had solutions in production for almost 4 or 5 years now. And so often the people who create those solutions aren't part of the company anymore. And so having machine learning models that are within the same framework, not necessarily just the same framework as the data science team and all of our solutions, but using the same framework that our internal development teams use. I.e., we're using DevOps and we're using similar DevOps systems and procedures, makes it a lot easier for us to maintain things when they fail and avoid, I guess, the problem that Owen is pointing out here, which is that anytime any machine learning ever has any issue, then you need to get the exact same person that made it to fix it. Because that, people move on, things change, and so you can't always rely on having the exact same person to fix it. And so by having MLOps and by using the similar system for all the products that we create, we reduce that risk.
Makes a lot of sense. And you guys both touched upon the fact that there are certain unique risks involved in the machine learning process, which need to be taken into account during practicing ML ops. And I saw Luca nodding his head when you guys talk about that. And Luca, I know you have a lot of experience working with machine learning assurance, basically taking care of the quality, the control of machine learning. Can you say a few words from that angle? So why do we need ML ops and why do we need to assure machine learning?
Well, the concept of why we need to assure machine learning is obviously a huge one and really relates to maturity of an industry, maturity of regulations, regulatory frameworks, and so forth. But let's just take it as a point of departure. We assume we need some sort of quality assurance, which is probably true for many cases out there. So why do we need MLOps? Well, MLOps certainly bring a new element to the table. We see, typically, at least in my experience working with my clients, we see that teams that adopt an MLOps culture, they tend to have a better management of their solutions in the long run. There's better maintenance and maintainability of their own solution. That's pretty clear. From my own line of work, I do see that, and I kind of want to tie back to what Stephen was saying with their Python packages, because I think he really had, nailed the problem here. He said, onboarding a new resource on a project can be cumbersome, can be difficult to kind of, walk this person through the whole workflow. And this is exactly, what I experienced personally when I approach, a new project from a third-party standpoint. And I see automation and the push that MLOps put on, importance they put on, converting processes into code is really helpful in that sense, because it really enables you, as Stephen was pointing at, that to kind of follow the workflows of a given team and be able to pinpoint perhaps elements of strengths or weaknesses. Yeah, that's pretty much from my angle what I see. But I second pretty much everything that's been said so far on the topic. Thank you.
Makes a lot of sense, and thanks for sharing from your angle as well. And obviously, yeah, sure, Rich, please go ahead.
Yeah,
go ahead.
Because you guys mentioned very good points. One of the things that Evan mentioned is about, for example, the failing of the API, which is different from the failing the machine learning model. And absolutely, we have seen in many projects, because that we have in the ML is the hidden. Say maybe it takes time to understand it's failed. So, for example, maybe we have the model drift, data drift. So absolutely, this nature is different from the failing of single API, and it takes time. So we need some procedure to mitigate and define those risks that can be happen during the project.
Yeah, thanks for adding that. So I was about to say that obviously responsible and ethical AI is a bigger topic, and from Microsoft point of view, we really want to empower data scientists and developers to not only understand responsible AI and machine learning principles, but actually practice machine learning operations in a responsible way. That's why we actually have a tool set called Responsible ML on Azure, for developers and data scientists to use to actually put the responsible side of things into practice. So for the audience, to check out. All right, so let's move on. So the next topic is really about, sharing your learnings and best practices so far. So I want to, ask each one of you to share one thing that is your key learning, or that is a best practice from you and your team from a machine learning operation point of view. Should we start from you, Stephen?
Yeah, so for me, the key learning is what I touched on earlier, which is people tend to take the shortest route to the goal they want to achieve. And if you put a lot of hurdles in place for a data scientist to get their model into production and into an end user's hands, then they're going to try and basically find the shortest way and probably go around a lot of those hurdles which are placed there on purpose. So for us, the key learning was creating internal Python package, which reduces the amount of friction for someone to release a model to production within the framework that we want. So this Python package, for example, just in terms of a concrete example of it, when it comes to running experiments, for example, in Azure machine learning, it can involve a lot of code which is repeated. And so we just created in our Python package functions which make the running of experiments just with one line of code, as opposed to multiple lines of code, because we tend to run experiments in a kind of uniform way across the team. And so we have a standardized way of doing that. So we just made a function that does exactly that. And it means that instead of data scientists running their experiments locally on their machine and having to, I don't know, write down in a note the results for their accuracy over time, then we're able to track those experiments within Azure Machine Learning, and we have a log of it. And so we're able to track the progress of the experiment. So that's just as an example. So for us, that's the key learning is creating internal Python package, which makes the MLOps process that we want as a team as the easiest path to follow, rather than making the MLOps process like or adding more hurdles to the work to introduce an MLOps process.
Yeah, makes so much point, because we need to have a process that works for us, not us working for the process, right?
Yeah, exactly.
So yeah, fantastic. Let's hear a few things, or actually only one thing from Irvin, because I know Irvin, you work in Crayon in Meta, and there's a big bunch of good data scientists, and you guys work with machine learning, MLOps on a large scale. But if you want to pick one thing about your key learning or best practice, what would that be?
I think for me personally, it was 2 years ago. I worked on a small team, and we were responsible for delivering kind of smart data solutions as a team. And so it was me as the data scientist. I was a data engineer who was a SQL expert and had full access to the data warehouse of the company. It was a fairly big company. And we were working then together with a full stack developer. And so I knew quite a lot about data science, but I didn't know best practices in how to get data or where to put this model after I built it. And the same thing went for the other two guys. And I think just working tightly together for a year and a half on, and really kind of seeing what was easy and what was hard for both for myself and for the others, and really iterating quickly on how to make things more available, how to implement feedback in a model when it was running in Kubernetes and you're struggling to store data, how to set up these pipelines, and getting insight into what part of getting data and cleaning data is hard when you have to navigate the data structures of a big company. I think for me, looking back, that kind of illustrates what you're trying to achieve with MLOps. You cannot always sit this tightly in such a small team and in the same room, but you can really facilitate a process where everyone on the project, all the way from A to C in the delivery process, so to speak, where everyone respects each other and everyone communicates clearly on how to achieve what they need to achieve. And I think that's important, and that scales from a one-man delivery team to very big teams that deliver much bigger solutions.
Yeah. If I may just add, my 2 cents here, because I think Irvin alluded to an important point. What I see, at least from my perspective, is that MLOps kind of promotes, differentiation or division of concerns, if you will, whereby you have different roles who will take care, of a different specific stage of your pipeline. And that's something that to me is kind of emerging as sort of a best practice whenever, a company of a certain size has the ability to invest in a team. You have the separation of concerns is becoming, very clear. And I believe that's something that MLOps essentially promotes in practice.
Makes a lot of sense. So Luca, in addition to what you have said, do you have any other key learning or best practice you want to share with the audience?
Certainly, I think we touched upon a point earlier on when it comes to reproducibility, the ability to kind of reproduce your model results at certain point in time, or whatever was deployed, a certain point in time, and you won't be able to, showcase how the model worked. So I guess my recommendation would be whatever helps you kind of achieving the reproducibility and keeping track of your model versioning as it was, of the history, so to say, throughout time. talking about, of course, a unique tagging of your code artifacts, versioning of the data, and so forth. That's obviously, those are big wins in MLOps context.
Perfect, thanks. Let's move to Shoresh. What's your best practice or key learning to share?
Actually, you guys highlighted very good points, and absolutely I agree with you. Same for me. I think that MLOps approach for those projects which I was involved first decrease the risk of failing by having the best practice and increase the productivity, repeatability, and the collaboration. So as Evan mentioned, we learned that we could look at the MLOps as a way to mitigate different type of risk. Very, very simple example I have here. You know that during the last couple of years, data science jobs were high demand, and probably some organization has experienced their talents churn without any doubt. So this is something clear that we have here from our customers and the different organization. And we had always the risk that the skill and the people to maintain the model are lost, and even getting worse. For some organizations which are depends on individuals, and still ML codes are in the data scientist laptop without having the fully automated ML orchestration and the process. So I think that MLOps here in this part also help a lot. Also, we learned that from the MLOps practice that we should take time beforehand to get the clear picture of how complex one ML project can be. As you guys mentioned that a couple of years ago, for example, for many companies, just the goal was that trying to make for the data science team, make how much great the ML solution and the ML algorithm with the high performance, and they forgot about the bigger picture. And another things that we have seen that many companies, for example, data engineering, data science, and for example, DevOps working independently. So we saw that the MLOps could increase those type of the collaboration, communication across different stakeholders, such as data engineering, data scientists, and DevOps. So personally, the key for me is that we learn how, for example, run AI projects successfully. And then we saw that, for example, how we were able to decrease this type of failing that we have seen maybe a couple of years ago.
Makes a lot of sense. And thanks for sharing, Shoresh. So we only have 3 minutes left. So I suggest we actually go into the questions from the audience. So let me, just pick a few, and let's have a very brief Q&A session. And for the remaining questions, obviously, we can take care of them afterwards, and we can send out and share with the audience after the event. So the first question I'm picking out of this would be, what would you say was the hardest step in adopting machine learning operations? So I'm going to throw this question to you, Evan.
No, thanks. The hardest step, yeah, as I've said many times, it's often getting people to work together and understand what you need to do, what your part is of the big puzzle that is to deliver something that works and builds on science, which a lot of machine learning solutions are kind of R&D projects that never ends. And I think, so one of the hardest things I feel, if you have a model that works, then from an ML ops point of view, one of the hardest things is to take seriously all the work that is remaining after you've delivered your first solution. And that is to really gather those logs, see how your model was used, whether it's a batch model solution or it's running an API, assessing whether the model is being asked to do inference on data that is similar to your training data, doing that quality assurance step. And it doesn't sound like that's the hardest part, but it very often comes, you have to do that after your budget has run out on the project and stuff like this. And it's normally not in the plan of the project and things like that. So it doesn't sound like the hardest part, but often it is my experience.
That's such a good point. So the next question, can we ingest data, retrain models, and deploy it to the production with Azure machine learning operations? So I'm gonna throw this question to you, Shoresh.
Yes, of course. That we can do many different things with the Azure machine learnings and create different type of pipeline for a data science purpose. But when they come to the MLOps, we need a better collaboration between the Azure machine learning service and Azure DevOps. If you want to look at the end-to-end solution, these type of platform, Azure DevOps and the Azure machine learning, both of them are essential for doing the task.
Thanks for sharing. So there's one question I will pick out as the last one. So how to convince the data scientists to work according to the MLOps principles? So I'm gonna ask you, Luca.
How do we convince them? Well, I guess we had a few very valuable points here. Separation concerns is certainly one. A data scientist, being in his own data scientist role, will get the chance to focus more on model development and model quality, I believe, and hopefully have the ability to pass on some of more architectural aspects to people who have maybe more a data engineering or a system architect role. Could be also, of course, shorter time to production and to value. More transparency in training jobs and performance metrics, possibility to do automated testing. It's also, I think, quite appealing. So these are, off the top of my head, some elements that I think should be valuable in this context.
Yeah, thanks so much for sharing. We are at the end of the session. Unfortunately, I do have, so much more to share. I'm sure the same for you guys. So let's, make sure we take care of the questions afterwards and share back to the audience. And for everyone who has tuned in today, thank you so much again for joining us. And please do reach out to any of us, for further discussions. And we would love to discuss further, how to do machine learning and machine learning operations the best on Azure. All right, have fun, guys. Take care. Bye-bye.